Hello everyone, my name is Omar Abu Hajar. I am with the Office of Structural Engineering. This presentation is titled Ohio Bridge Railing. This is for the implementation of specifications of National Bridge Inventory, roadside hardware. First of all, let's talk about some dates that are going to be important for us as the whole state trying to get in compliance with the federal highway requirements. Effective starting in June of this year, 2022, the SNBI became effective. That means we can start implementing the inventory that was published back in March. The state has an option to submit the legacy data plus the new SNBI data starting in 2024 and 2025. ODOT must complete the SNBI inventory in 2026. So 2026 is very important year where everybody's going to hustle and complete all of their bridge inventory so that we can submit the data to Federal Highway Administration for review and approval. Usually Ohio submits the data in March of every year, so that would be in March of 2027 is our absolute deadline. So what do we need to do for regarding this presentation is we have two items regarding the bridge railing and bridge transitions, the bridge terminal assemblies. Two pieces of information that will be very important to us to submit accurately. That includes the test level for the railings and the test level for the BTAs. So this slide presents moving from legacy inventory into the new specifications. We're moving ahead. A little bit of background. Ohio had an item 407 that we used to collect the bridge railings in our inventory asset-wise. So this slide contains the top 10 by bridge count, organized by railing type for item 407. As you can see, the highest is steel guardrail. That has about 14,000 bridges. Second is none, which that seems to be an error, or the data was not populated by the inspector at the time. So anyway, whether it's error or whether it's lacking, it just gives us an idea that the existing data in the inventory cannot be transferred one-to-one ratio. We have to do some work to get in compliance and complete the data to be able to submit it. So with that, we look deeper into the data and ASSETWISE, and we were able to convert those bridge types that are included in this slide. However, the conversion only includes the bridge railings. It does not include the transition information. From this data, we were able to convert the bridge type into test level based on our information from the BDM or standard drawings, where it indicates the test level for each type of those bridges. So we have about maybe 7,000 bridges, maybe a little more, that we were able to include. That leaves a big chunk of the population of those bridges that still remains to have some work done regarding the bridge type. This slide contains, it's a snippet from the SNBI, section 2.3, roadside hardware. We have two items to consider, BRH01 and BRH02. O1 is for bridge railing and O2 is for transitions. And all we have to do is indicate the test level for those two items. This slide also was taken as a snippet from the SNBI. It includes information on how to fill out the inventory for those items, for those two items I just mentioned. Just to briefly talk a little bit about this slide, we go from bottom to top. Bottom is the lowest level, it means bad, and top means high or good. High means MASH testing or not needed, not applicable or not needed. That's the best situation, but that's not applicable really for most of our bridges, or if not all. We start with the MASH testing for each test level. M indicates MASH. Then we go down the step, NCHRP 350, NCHRP 230, 239, and so on. Going down the list here, I indicates that the railing is needed, but it has not been crash tested, or it does not even have an ODOT or Ohio standard for this railing. The S indicates that the bridge has not been crash tested, but it meets the standard drawings or the standards, the railing standards of ODOT. With that, it doesn't also mean that it should be current. So any standard railing that was done in the past and maybe have been retired, that will take it to the initial S, unless it has been crash tested and have been proven that it is not worth it, it does not meet those standards. So that will revert to an I. We'll go here. This slide just pictorially show you the transition for the NCHRP starting in 1964 to 1993, 1993 to 2009. We have a new another update of those crash testings, and finally we go to the MASH testing starting in 2009. Another information on this slide or this photo is showing you the bridge railing. It is the actual railing that is installed at the bridge, then connected with the transition. This transition that is named by Federal Highway Administration. In Ohio we call it the Bridge Terminal Assembly or the BTA. Sometimes in Ohio we have concrete barriers that have a transition in shape and size to meet the bridge terminal, where we call that a transition. But for federal highway, that will not be transition, that is part of the rail. The transition will be the component that connects the rigid rail and it transitions into a flexible rail, which we call the BTA. Ultimately, once we do the field work and we know we have a very good idea what type of rail we have at the bridge and what type of transition we have at the bridge, we can go to ASSETWISE and populate some information. As I indicated earlier, we're only concerned to submit to Federal Highway the O1 and the O2. We set up those two fields to be read-only, and they are internally calculated by ASSETWISE, and this is for the purpose of making the task of populating this information a lot easier. As you can see, this information, it can be very difficult to memorize, considering the M and the SS and the I and the 0 and the X and all that stuff shown in the previous slide. Rather than trying to memorize that, what we tailor this this information in ASSETWISE is where you can enter the material of the barrier or the railing. In this light, it shows it is concrete, it can be steel, or it can be other for masonry, or maybe wood, or things like that. So if you choose to have it as a concrete barrier, then the list narrows down to what, we have a certain standard railings that are concrete. So it narrows it down to different types, and we have those listed based on some compiled information from all of our standard drawings, and all of the information that ODOT has about bridge railings with regards to test levels. Once we determine if it is a jersey barrier, if it is a single slope, if it is a portable barrier, etc., then we can measure the height of this railing, and based on the height, it will give us, indicate to us that code that we need to submit to Federal Highway. For this specific railing, it's a jersey barrier, but we call it the GM. That is prior to 1979. It was not crash tested, so it is coded as an I here. For that too, you look at the bridge end and see what bridge terminal assembly that is, and based on the type, then that also calculate to have that. So that looks like a MASH for type 1. It's a MASH 93. I will talk more about this form and how to fill it out. So this is to just indicate what we use to compile all this information. We use the BDM to get the test levels. We used retired and current standard drawings for railings, and also for the bridge terminal assemblies. And this is from the BTAs are published by the roadway design people, and the bridge railings, obviously, they are published by Office of Structural Engineering. Early on in the process this year, we compiled all of the information about all those standard drawings, sizes, names, standard drawing, whether it's current, when it was published, if it has been retired, so on and so forth. Our standards folks have also compiled or provided the test level for each railing type, compiled all that information, make sure we can reference it, we can link it, we can review it, and such. Finally, we had a very good handle on what we have at hand. From this information that we compiled, we created a guide. This guide will lead into that screen I showed previously that leads you to go and populate the information in ASSETWISE for the inventory. The aim is to have no memorization, is to go narrow down your list and use a little bit of judgment and a little bit of intuition, and be able to finally get the fields calculated for you successfully. So the idea is to have visual identification rather than try to research and go back to standard drawings and such. Just visually narrow down your search and be able to successfully complete the inventory. With that, we created a bridge railing appraisal guide that can be used for reference as well, and also documents how we arrived onto those codes in ASSETWISE. At this moment, I would like to have a shout out to Jalen Faircloth. He is our intern, and he helped in putting help with the guide, creating the guide and putting all this information in the presentation format. The guide is divided and organized in certain way. It's based on material type of the railing. If you have mixed material for the railing, use the type that connects the railing component to the deck, so that whatever connects, if it's concrete, that would be a concrete rail. If it's a steel. If you have composite wood for panels and stuff, that we will not call that as wood. If the component that connected the post to the deck is steel or concrete or different material, that is the material that we will call this bridge type with. So back to this slide. So we have concrete, we have steel, we have other, that is for masonry or wood, and then finally we have also the bridge terminal assemblies as well included in this guide. This guide also subdivides those concrete into different types as well. Single slope, parapet railings, those for the sidewalk railings and maybe safety curbs and that stuff. That's for parapet. There is a certain amount of bridges that have concrete post railings in New Jersey, and the portable concrete railing. Some examples about this. For concrete, we should talk a little bit about the General Motors deflector parapet, 32-inch. It has been retired. It's called BR167. We code that as an I. In the guide, we provide a snippet of the standard drawing just to give the inspector an idea on the shape and the dimensions. For example, this one we highlighted the 1'5" dimension. This dimension makes a difference because this type of rail, it has not been crash tested. Compared to another type, a newer New Jersey type 32-inch. It has been also retired, but it is TL4 compared to the I. The difference is the other General Motors barrier has that this dimension measures at 1'5", so the shape looks the same. It's very easy to make a mistake. We wanted to help the inspector to identify those barrier types. Just be sure when there is confusion about which way to go. That other dimension was 1'5". This dimension is 1'7", so it's easy determined from field or maybe from the plans if they don't call it out. Another example is the steel. It's a parapet with steel tubular rail, TL4. The guide provides all this information regarding the rail, including the height, so we need to measure the height and to verify that. Material makes a difference. Aluminum hard rails are not crash worthy. Steel is. It's a newer rail. If you measure the rail height from the top of the steel rail to the top of the deck or the sidewalk, it should be 42-inch. 42-inch is a good height for crash worthiness to meet those test levels. This is a mesh test level in 1994. Another type for concrete barriers is the 36-inch high single slope. Similar to the previous bridge, we give you the information so you can very easily identify and populate that information in ASSETWISE. Another example is the 42-inch deflector shape. There is more in the guide than that for the interest of saving some time, because the information is presented in very similar fashion. there is no reason to go through each railing type. I would like to give you examples and briefly touch on those if there is any difference between those railing types. Another section of the guide is for steel railings, and we also identify them by different types. For example, the deep beam, the tri-beam, twin steel tube, long span for culverts. The newer one, the most recent one, is the 3 steel tube rail and the steel post. Here is the example for the tri-beam railing with identifying the ash to test level and giving you the required height to measure in the field. This one is a tri-beam retrofit, so this looks like a safety cord that maybe the owner came back and removed the old rail and put this tri-beam because it is better, performs better for crash testing. Twin steel tube, this is more recent. We can go over the other rails. As I indicated before, masonry is other rail. Some municipalities or local agencies or park districts might want to use this material. It is an I for test level. All this material has not been tested and may not even be in the standard. Another shape of masonry railing. And here is the section for the terminal assemblies. We identify them also based on the standard drawings and based on visually what they look like. So this one looks like a type 1, a recent one, TL3 for MASH. Here is one example for no railing, so that would be code 0, because we don't know if the car cannot traverse back to safety, so they might keep going and they might just flip the car over if they hit this wing wall. So that would be code 0. This slide provides a listing of all the bridge terminal assemblies. The most recent ones are the MGS and some older ones, retired. We found them in the retired standard drawings. They still exist, so there is no reason to go and remove all of the railing for about 45,000 bridges to make them up to current standards. So there is a policy on how and when to replace those railings and those bridge terminal assemblies. So if they are retired and as long as they're there and they're functioning still, we keep them until there is a criteria that whether we are replacing the deck or whether we're doing rehab on the superstructure or things like that, or going through the criteria that will dictate whether we will need to update those railings and those BTAs into the current standards. But so yeah, we have to account for all the types, including the retired ones. So that shows you the type 1 from the guide, the standard drawing for it with the dimensions in case there is a confusion. Type 2 usually is provided at the exit when you exit the bridge, and there is no attack angle to consider there because you're exiting. So that would usually in our current standards we provide a lower performance of the terminal assembly than the ones that approaching the bridge. But it is in there in case some owners have it at the approach end of the bridge, so we can at least include that. Use type 2. With that, this concludes my presentation, and I hope you found this very useful to you. I recommend for you to download the guide from our website and to go through it. And once we make the new SNBI form available for everyone, I suggest that everyone can go there and click on those the roadside hardware section to get acquainted with this task to populate this information. I am considering to add another an addition or a second part of this presentation, maybe a tutorial about 5 or 10 minutes just to go through and populate those railing types and such in ASSETWISE. One thing to keep in mind that this information, it's only two items that we need to include in the inventory. The bridge has a left and a right. Usually what you need to do is we need to just report the lowest functioning test level for those bridges. So if there is a left and right, say you have a curb that does not meet crash testing, an older standard handrail, and on the other side you might have something, maybe a single slope that meets TL4 or TL3 or something. So you don't want to report the TL3, you want to report the I for the sidewalk that has not been crash tested yet. So try to just use judgment with that and try to reduce the amount of work and the amount of information we need to populate in ASSETWISE by initially picking the lowest test level and then add this information to the inventory. With that, I'm going to leave my contact information. Please let me know, send me an email or give me a call if you have any questions. With this, thank you very much for your attention and good luck, and hopefully that you have successful inventory work in the upcoming 3 years. Thank you very much.